Okay, this problem is AMC 10A, problem 16, and AMC 12A, 2023 problem 13. It says in a table tennis tournament, every participant plays every other participant exactly once, although there were twice as many right-handed players as left-handed players. The number of games won by left-handed players was 40% more than the number of games won by right-handed players. There were no ties and no ambidextrous players. And what is the total number of games played? Okay. So here, suppose it says number of there were twice as many right-handed. Okay, so as left-handed. So R equals 2L. And we can say what? We can say, okay, it is R, which is 2L. It is L. Number of games equals what? And N is R plus L. Okay, number of players. What is the total number of games played? It will be N choose 2. Okay, because each two player plays exactly once. Here the problem says. N is R plus L. We want to find N choose 2. So let's calculate each choice, and we know R is 2L, so 2L plus L, 3L. For choice A, if it is equal to N choose 2, N choose 2 is N times N minus 1 over 2. So for choice A, N times N minus 1 over 2 is 15. So N times N minus 1 is 30. And N is integer. So positive integer. N is what? N is 6. Okay, for first one, N is 6. For choice B. And we cannot reject this because 6 is multiple of 3. For choice B, N times N minus 1 over 2 is 36. So it is a necessary condition, not sufficient. N times N, we want to see we can reject which choices. N times N minus 1, 72. 9 times 8, 72. So N is 9. Let's check choice C. N times N minus 1 over 2 is 45. And let me tell you, number of games played in this part, in graph, we can call it idea 19, idea 20, 21, 22. Okay, this part. In graphs, we have this idea. In tournament, we have N choose 2 games. So this one is N times N minus 1 equals 90. So N equals 10. But this one doesn't work because N should be 3L. So we could reject choice C. For choice D, N times N minus 1 over 2 is 48. So N times N minus 1 is 96. It's not possible because if you consider, for example, 10, let me check. For 96, for example, if we check 15 or 11, 11 times 12, or let's check here. 11 times 12, or let's write 12 times 11 over 2 is what? Is 66. Okay, so it is greater. 11 times 10 over 2 is 5, 45. So this one is 45. Next one, two consecutive triangular numbers. Here we call these numbers triangular numbers. 48 is between these two consecutive triangular numbers, which we can conclude there is no n. So we can reject choice D now. Last one, 66. Okay. For choice E, 66, n times n minus 1 over 2 is 66. So by considering this, we can consider n equals 12. Okay, so here n equals 12. And here n equals 9. Here n equals 6. Something, sorry. Let's say 12. No, that's okay. Now let's see which one is possible. It says number of games won by left players was 40% more than the number of games won by right-handed players. Okay, so W, let's see, won by left-handed was 40%. Okay, WL is 1 plus 40% times WR. Okay, and we know WL plus WR equals W number of games. For example, look, when we have three things, if we consider winnings of all players, we calculate each game once from the winning part, from the winner. So W equals n choose 2. And we can say, okay, this is 1.4 WR. So if we replace WL is 1.4 WR plus WR, it will be 2.4 WR. It will be what? It will be 24 over 10 WR. So n choose 2 is 12 over 5 WR. If you multiply both sides by 5, 5 times n choose 2 equals W that 12 WR. So we can conclude 12 divides 5 times n choose 2, and by Euclid's lemma, I told Euclid's lemma before the exam, idea 22, idea 23. Euclid's lemma. I told this one before the exam. It's an obvious lemma. If A divides BC and GCD of A and B is 1, then A divides C. Okay. So 12 and 5 are relatively prime, so by Euclid's lemma you can say 12 divides n choose 2. Now we want to see which choice is multiple of 12, not A, not E. So the answer is 36. Okay. Now let me tell you example for this 36. For this one, n is 9. Okay, so because n is 9, L will be what? L will be 3 because it's 3L. Here 6. We have 6 right-handed, 3 left-handed. Let's try it like this. And 3 left-handed. And here we consider, okay, it's like this one. It is not important between them. It is what, but we consider all edges between them from this part to this part. When we consider this one, A wins B. Okay. Now I want to say this example works. How? Here we know, for example, this one is right-handed equals 6, left-handed equals 3, WL equals 1, 2, 3, 3 edges here, plus 3 times 6, 18, 21. WR is what 6 choose 2 because each game here has one winner. Is 6 choose 2, which is 15. And now I want to say 21 is 1 plus 40% times 15. Let's see, is it correct or not? 1.4 times 15, which is 14 over 10 times 15. We can cancel 2 by here, 7, and 5 by here, 3, 21. We will see it's correct, okay? We wanted to check this, and this example works, okay? You don't need to find this example. If it was for example, use some full solution exam, you have to find an example. Maybe also we have some other answers except 36, but if you consider the choices, 36 only possible. Okay, if you had question or wanted to learn more things, like this one, important ideas in number theory, Euclid's lemma, and many multiplicative inverse, many important ideas, 40, 50 important ideas in each topic, feel free to send message to my WhatsApp number in the description.